Hey guys, what's up? You're watching episode number 5 of NoDev to GameDev, and today I'm going to be teaching you about your second control structure, the loop. So we're going to be going over all three types of loops, the while loop, the do while loop, and the for loop. And these are going to be essential for your programming. This is really important shit, so do not click away. And let's just get into it. 2 videos ago, we learned about if structures, which allowed us to control whether or not a particular chunk of code would run. Now, in this video, we're going to be learning how to write loops, which will essentially allow us to run a chunk of code over and over and over again until a certain condition is met. So where if statements would run or not run, depending on whether that condition was met, loops will they will run if the condition's met, and then they will continue running until that condition is false. So that's the main difference between if statements and loops. So as I mentioned earlier, we have 3 types of loops: while loops, do while loops, and for loops. The first one, the while loop, is the most basic, it's the most versatile as well, and it looks very similar to an if statement, except where you'd write if, we instead write while. So that's just going to look something like this, where we put a predicate between these 2 parentheses, and as long as that expression is true, the chunk of code in between these braces will run over and over and over again until that predicate is changed to false. Next, we have do while loops, which are very similar to while loops, except they're guaranteed to run at least once, because they check whether or not to continue at the end of the loop. So basically, they'll run through the code and then check whether to continue. And if it evaluates to true, then they'll go back to the top. Whereas with while loops, it will check if the condition's true, and if it's true, run through it. So you can see do while loops will guarantee at least one run, whereas while loops can possibly run 0 times if the condition is never true. So I'm just going to throw in an important sidebar here, because we've been able to get so far with predicates that make single comparisons, but we can also combine predicates with a few operators I'd like to introduce. These operators are the and, the or, and the not predicate operators, and you can use them together to basically make larger compound predicates. So what basically differentiates them from the other predicates we've looked at is that these 3 operators operate on true and false values. So for example, where the equals equals sign, the equals equals operator, I should say, operated on, say, if the left number is equal to the right number, it would evaluate to true. The and, the or, and the not operators, they take in logical values such as true or false, and then we'll use those to compute another true or false value. So I'm just going to explain them. I think it'll be a little more clear when I give you the practical explanation. Take the and operator, for example. It'll take in 2 logical values on either side. Say if it's true and true, then and will evaluate to true. If it's a true and a false, it'll evaluate to false. And if it's both false, they'll evaluate to false. And I'm going to have the logical tables up on the screen right here so you can kind of see how the operators will evaluate in each case. So basically, with and, if they're both true, then it's true. Otherwise, it's false. Now, the or operator is very much like the and. If they're both true, then it still evaluates to true, like and. But if one of them is true and the other's false, it'll still evaluate to true. And the or operator will only evaluate to false if both values are false. The third operator will only take in one value. So where and or took in 2 values, the not will only take in 1 value, and it basically takes in a true value and switches it to false, or a false value and switches it to true. So we can use these to make big compound predicates, which end up being very useful for loops. Say, for example, we wanted a number to be equal to 1 or equal to 2. We could have our variable equals equals 1, and then the or operator, and then our variable equals equals 2. So now if either of these evaluated to true, then the whole statement would evaluate to true. And so I'm sure you can think of a lot of different examples of how this could work, but I'm just going to leave you with that. I think you can figure it out. It's not too complicated. Anyway, so let's move on to our third and final loop, the for loop. So the for loop is a little different in that it's structured very differently from the while and the do-while loops. The while and do-while loops are designed to repeat until any predicate is met, but for loops are used specifically to repeat a certain predetermined number of times. For loops start out similar to a while loop, except instead of having while, of course, they say for. So for, and then the parentheses, and so on and so forth. It's not until we start looking inside these parentheses that we start seeing the main differences between for loops and while loops. So the first thing you'll notice is that a while loop will have a single predicate, whereas a for loop will have three distinct statements. The first one, we're going to need to assign a starting value to the variable that we're going to use to count. Our program needs to know what value to start at so that it can also count up to the value that we want to end at. So the first statement will be an assignment, where we just assign the base value to our counting variable. The next statement is going to be a predicate, just as you'd expect, because our program needs to check whether that counting variable has counted up to the end value. The third and final statement will be an increment statement, where we add or remove or somehow change our counting variable to move it towards the maximum value. So just to give you an example, we might be counting up to 5. Say we want to run this loop 5 times. So we'll set our counting variable to 0. That'll be the first statement. The second statement will be our variable is less than 5. And then the next statement will be our variable plus 1. And so this will basically run for the variable equals 0, then for the variable equals 1, the variable equals 2, the variable equals 3, the variable equals 4, so that's 5 runs, and then the variable will be incremented to 5, and the predicate will change to false because 5 is not less than 5, and so the if statement will end. So that's basically it for a for loop, but before I move on, there are 2 points that I'd like to touch on. So the first thing I'd like to note is that you don't actually need for loops. You can actually just create a while loop that has the same functionality as a for loop, and I'll give you an example right on the screen there that you can see. This will run exactly the same as the for loop that you see on the screen just below it. They both have the same functionality. We just use for loops to communicate what our code is doing to somebody who might read it. If you use a for loop, it sort of tells them, okay, we're counting up from one value to another. So that's generally the idea of it. The next thing I'd like to bring up is an increment operator, which is basically an operator that takes a variable and adds 1 to it. So as you can see here in my for loop, I've used an increment operator, which is just this little plus plus. Say if you want to increase a value by 1, you use the increment operator, and that will add 1 to it. If you want to subtract, you can use the increment operator's twin, which is the decrement operator, or minus minus, and that has basically the same effect. It just takes 1 off. So I guess the same effect in reverse. Just a little note though about increment and decrement operators. You can put them before or after the variable, as you see on the screen there, except if you put it before the variable, it will add 1 to that variable and then return the value. So say we say j equals plus plus I will have 1 added to it, and then j will be assigned to the new value of I. Whereas if we write j equals I plus plus, j will now equal the old value of I, and I will equal the old value of I plus 1. So that change isn't tracked until after its value is assigned to j. So that's just a small difference, but if you notice any weird behavior, that's basically what that's coming from. The placement does matter with these increment and decrement operators. Now, there's one more thing that I'd like to discuss, just one more bit of, a tidbit of theory that doesn't really fit in, but basically, you have to watch out for infinite loops, and that's basically a loop where the predicate never becomes false. The most obvious example would be 1 equals 1. So that is always true because we have a set value and we're comparing it to the same set value. Now, neither of those values are going to change. The value of 1 will never change, and the value of 1 will never change, and they'll be equal forever, and your program will never decide to terminate. It'll never run through that loop, and that will just continue on forever. And your computer's going to see this and go, okay, something's wrong here. I got to shut this thing down. So it'll shut it all down, and your program will essentially crash. So just watch out for that. If you ever find that happening, that your program is just suddenly crashing or whatever, that might be the cause of it. Alright guys, so that just about wraps up the theory part of this video. So now let's apply these concepts to our game so that our game will run until the battle is done, instead of just running for a single turn. Even if you're not working on this game at home, even if you're not following along, I think it's really important if you watch this part just so you can see how these concepts would be applied in an actual program example. Okay, so let's get into it. First things first, we don't know exactly which loop we want to use. So do we want to use a while loop, a do while loop, or a for loop? Now the first thing that we think is that our game could take an unknown amount of time. We don't know how long it's going to take, because what if both characters keep attacking and they keep missing? So that would take, an unknown amount of time. It could take forever in theory. I mean, if we got really unlucky. So what you have to think is for loops aren't going to work, because for loops are used when you know how long the loop will run for. But if we don't know how long, then we're going to have to use either a while loop or a do while loop. You could use really either, but in this example, I'd like to use a do while loop. And the reason for that is because we know the battle won't start if either our character is at 0 health or the enemy's at 0 health, because the enemy always starts at full health and our character starts at full health as well. So neither character will die right off the bat. So we always want the game to run for at least one turn. And for that reason, I think we should use a do while loop, because that asserts that we want this turn to run at least once. So just as we did in the example, I'm going to start by writing do before the first line of code that we want repeated, which is basically the part where we print out our health. So we write do and then a bracket. And then after our code that we want to run, I'll write the closing bracket followed by while with parentheses and a semicolon. Now, it's really important to remember the semicolon. It always gets me because you don't have to use a semicolon for the while loops. You don't have to use it for the for loops, but it is important to have it after the do while loop. And that's just a weird thing, but keep that in mind. So now what we need to do is we need to write a condition for what will make our loop stop. And basically the way I think through this is, all right, so if our character dies, if our character has 0 health, we want the game to end. But if our enemy character has less than or equal to 0 health, we want the game to end then too. So there are 2 requirements for the battle to continue. The player must have more than 0 HP, I should say, and the enemy must have more than 0 HP. So this is an example where we have 2 predicates that we need, and so it's a great time to use the AND operator. So first what we're going to do is assert that our character's current HP is greater than 0. Then we'll write our AND operator, and then we'll write a predicate that asserts that our enemy's current HP is greater than 0. So as you can see, if either one is less than 0, then that will make AND evaluate to false, and the loop will end. But if both of them are true, if both those predicates are true, the AND will evaluate to true, and the loop will continue running. So with all this done, I'm assuming that you, in the third video, added the enemy attacks the player code. If you haven't, then I would suggest you go back and check that out. But assuming you have, we can run this and we can watch the battle play out with one player or the enemy randomly coming out ahead, because they're both basically on even ground. Anyways guys, that's about it. So I'm going to end this video right there, because at this point, we've learned about all 3 types of loops, we've learned how to implement them, and we've learned about a few new types of operators. So this game loop that we've implemented is going to be a really critical part of our game moving forwards, because it sort of drives our game. So you're definitely going to want to check out the next video. Please like, subscribe. If you need any help, you can check out the GitHub. And as always, thank you very much for watching. I really appreciate it. I love making these videos, so it means a lot to me when you guys hit that like button. Anyway, I'll see you next video.